And we didn't quite get this in one go, but we're getting close here. So we've just submitted the data to the buffer. Now before we actually start playing that, we actually have to use the XMA update method in order for these buffers and everything to work here. So Microsoft XNA framework, and I'm trying to remember framework dispatcher. There we are. Alright. Now if we start to play this, it actually won't work. Oh, well, first of all, I didn't even tell it to play. I've got a couple things we still need to do here. Audio player, play. So this is going to stop because we're not doing any more of these update methods. We need to call that on a regular basis. So we're going to use the real quick shortened version of the fast game loops that you'll see a lot of times in tutorials here. So we need to go to application, which I can't spell, and we need the idle event. So, oh, come on! Didn't auto create. Application idle plus equals plunk. Alright, so this is going to just call this idle thing when the application is not busy. And I'm just going to dump this code in here just to make things quick and easy here. It's got a couple pieces to it. This needs to be pulled out. So this is checks the messages in the stream to make sure that things are still sleeping. He's just going to hang out up here. Just move him real quick, because he's not going to be happy inside there. Now he's going to be... Oh, no, he's not, because I have to do interrupt services using system no. System Windows... I can't type today. System, Windows, nope. I can't remember what it's called. That's under runtime, isn't it? There we are. Haha. Now we got that running. So now we've got a while loop here, and we can run the pieces we need out of this. Boy, I got a mess going here. Just clean this up a little bit. So while, you know what? Let's do, here, fix yourself. There we go. So now we're going to run the Soft XNA framework frame dispatcher update within here, and do one more thing here to make sure things keep going. We're going to let the system sleep, so we need using system threading. Oops, got carried away there. Where was that? So now we can do thread sleep, and we're gonna just sleep for one frame. It's 1/60th of millisecond. 16 milliseconds is 1/60th of a second, which is an average frame rate. Now the other thing we need to do, we only have 70 samples. That's not even a second worth of data. And this is one of the things I really like about this dynamic sound effects. You can check and see how many buffers are present, and there's also an event we can subscribe to for that. So we're just going to use the subscription event to make this work. So audio player, and buffers needed is the we're going to subscribe to, and do the same thing we did in the original. We're just going to add a new buffer. So every time there's more buffers that need to fill, this is going to get called. So we're just going to do generate wave data, convert to BCM, and audio player submit buffer, and it's the PCM data. Oops. So we should have all the pieces we need for this to run. Let's just go ahead and do a real quick debug. We should get a really annoying sound. So that's not the frequency we expected. That was not a clean sine wave, which probably means I got my Indianness backwards when we converted here. So no harm, no foul. We'll just change the order right here that these bytes are submitted. And if all goes well, it'll sound much better this time. Alright, we got a little bit of an issue there with sound. It might be our sample's too small, or my pause might be too long. In that event, I got a little bit of a mess here, but I just wanted to show this thing working really quickly. So where is that? Where are my events hiding? This is why you shouldn't write code like me. I might write very messy stuff. Wait, right there. So I'm just going to bring this down, see if that's where we're getting that break in audio. Yep, so it's because I'm recording. It's taking some clock cycles away, so I needed to bring that number down. When nothing else is going on, 16 is probably good enough for that to work. So now that we have that working there, we're just going to demonstrate that sweeping doesn't cause a problem. So how are we going to do that? Well, we're just going to develop a way to change our frequency here. So wait for this to populate here. We're just going to use this guy right here. And I'm also going to go ahead, let's just make a little box here, so we get a result. And we're going to go set our frequency range that we can change to. So where's our min value max? Minimum 0, yeah, why not? Maximum size, there we go. Maximum, so we're going to go, we can go up to 7K. So just set up an event for this to change. So we're going to set frequency to, oh boy, what's that bar called? Track bar, we didn't rename it. Track bar 1 value. And let's do our text box. So what did I call that? Frequency display text box text equals frequency to string. Oops, got carried away there. And now it's going to start at 1 kilohertz, but I can sweep this. And we're not getting... let me turn that down because you probably can't hear me over that. And I've run out of time here real quick, but you can see that there's no noise generated by that sweeping.